The question says, what is the remainder when 13 to the power 2013 is divided by 100? This question can also be rephrased in CAT as what are the last two digits of this number? Because when you divide something by 100, the remainder that you obtain is always the last two digits. Okay, that is kind of commonsensical. So let's try and do that. 100. So we can do it in multiple ways. What I will do here is I'll use the Euler's theorem. So first of all, let me calculate the number of co-primes to 100 which are less than that by using Euler's function. So phi of 100 will be equal to, okay, first of all, I need to factorize 100. That is 2 square and 5 square. So 100 is made up by various combinations of 2s and 5s, 2 square, 5 square at max. So we are concerned with finding the co-prime numbers to 100 that are less than that. So for that, I'll just multiply 100 with 1 minus 1 by 2. This is how I'll be obtaining all the numbers till 100 that are not divisible by 2. 1 minus 1 by 2, I have removed all of them. And from those removed numbers, I need to remove all the numbers that are multiples of 5 as well. Once I do that, what do I get? 100 into 1 by 2 into 4 by 5. 2 5s are 10, so 1 is 40. Now, it means that there are 40 co-primes, 200, which are less than that. According to Euler's theorem, what happens? If I have any number, let's say number is a raised to power phi of n, mod n is always equal to 1, which means if I want to divide something by 100, and the power here is 40, or a multiple of 40, the remainder will be 1 always. That is what the Euler's theorem mean. Moreover, a and n should be co-prime. That is the condition. They should be co-prime. Are they co-prime? Yes, absolutely. Because 13 is a prime number and 100 is made by 2 and 5. They are co-primes. So basically, we can use this. Now, having said that, 13 to the power 40 and any multiple of 40, let's say 40k, mod 100 should be equal to 1. Here we have 2013. What is 2013? Is 13 to the power 40 multiplied by, let me break this, 40 5s are 200, 40 zeros are 2000, multiplied by 13 to the power 13. That is how I have broken this. 14 to 50 is 2000, remaining is 13, mod 100. Now, as I see here, for the first term, the remainder will be 1. All right. So we have 1 here. Now we are only left with 13 to the power 13 mod 100. So Euler's theorem basically reduces the calculation. And here is the main calculation that we need to do. How to do that? First of all, note this down. I'll wait for 5 seconds. 5, 4, 3, 2, 1, 0. I'll just use this and erase everything else. So 13 to the power 13 mod 100. So what I did here can be done mentally also. Once you practice some questions on this theorem, automatically in your mind it will be like 500 is 500, 100 is 40. So divide this by 40, 13 is left. And the very first step that you can write is this. Once you've done that, we need to find a pattern here. Okay. So 13, I need the last two digits. All right. So I can write this as 13 square into 13 square into 13 square into 13 square into 13 square. So how many do we have? 1, 2, 3, 4, 5, 6, 13. All right. So I made it this way because that is how you can understand this easily. So what do we have here? 13 square is 169. And we need only the last two digits. All right. So instead of taking 169, I'll take 69 only. 69 here. So there are loads of 69. How many are there? 1, 2, 3, 4, 5, 6. And then a 13 mod 100. What should we do now? If I divide 69 by 100, I'll get the remainder as 69 only. So I'll just club these values. So I can have here 69 square multiplied by 69 square. One more 69 square. Now this can be done, kind of mentally also, but I'm just expanding all these steps. And 13 is as it is. So the square of 69, how do we find that? Now you'll be surprised, or you will be kind of, worried about how to find square of 69 quickly. But thing is, we need to find the last two digits only, because those two are only relevant of this square. Here lies a theorem that is called Mool Varga Siddhant. In that, what happens, if we have any number that is x more or x less than a multiple of 50, then its last two digits will be same as the last two digits of square of x. So in this case, if you see 69 can be broken as 50 into 1 plus 19 whole square. So the last two digits of this number will also be the last two digits of this number, 19 square. 19 square is 361. That means we have the last two digits are 61 here. 61, how many times? 1, 2, 3 times. And then 13 is already there, mod 100. What next? So obviously, you must have understood, I'll be clubbing these two, 61 square, then a 61, then a 13, and I do the calculation later on. 61 square. Now I can break 61 square here as 50 plus 11 whole square. The digits will be, last two digits will be same as 11 square, which is 21. I get 21 here. Okay, so I get 21 here, the 61 already, then 13 mod 100. That is what I need to calculate because everything else has been calculated. Moreover, what looks very tedious and long to you is not really long because this can be, lot of things can be done mentally. I'm going to skip some steps as well. So now I'm concerned only with that, those values. Okay, how to solve that? I'll go by normal multiplication. 21 into 61 into 13. So, and also I need the last two digits only. So the rough work, I can do this 61 multiplied by 21. Let's see what's going to happen here. 1 ones are 1, 1 6 are 6, 2 ones are 2, 2 6 are 12. 1 comes here, 8 comes here, 2 1. Now thing is, only these two are relevant, not anything else. Alright, so 1 ones are 6, 1 ones are 1, 1 6 are 6, 2 ones are 2, 2 6 are 12. We are concerned only about the last two. We have 81 here. These two will club up to make 81, then into 13 mod 100. Just multiply 81 and 13, 13 ones are 13, carry over 1, 13 is a 104, plus 1 is 105. Again, we need only these two. So this becomes 53 mod 100. And that's all. The answer is 53. Seems tedious and long, but once you practice this, automatically a lot of steps will be eliminated. Thank you.